So welcome to experiment 3. We'll be looking at our concepts of electrical resistivity and conductivity. So the aims of the experiment are to understand the concepts of resistivity and conductivity. It's also to show that the electric field inside a good conductor is uniform, and also to determine the resistivity and conductivity of this material, the stainless steel alloy resistor. So first of all, I'd like you to read the theory on Ohm's law, and the equation 1 in your notes is a very important relationship for this experiment, which relates the resistivity to the resistance and the length and cross-sectional area of the wire. So there's a proportionality there in that equation that you must come to terms with. So also I'd like to bring up the point that resistivity is something that is intrinsic to the material. So it's a particular material has a type of value for resistivity. The resistance changes depending on the length of the material and the cross-sectional area. So that's the two differences between resistance and resistivity. Now conductivity is just the inverse of the resistivity. So it's 1 over the resistivity. That's the relationship between resistivity and conductivity. Something you also need to know for this experiment is the relationship of resistors in parallel and in series. So please review that. There's a section in your notes that shows you how to add resistors in series or in parallel, and also review V equals IR, which is Ohm's law. You also need to know an equation for the current density inside a conductor, and also the equation for electric field given the voltage drop across a resistor and the distance, the length. So the apparatus that you have to work with here, you have a multimeter here, a digital multimeter. Now it can measure very accurately resistance and voltage and current, etc. So we also have a power supply here. It's a current controlled power supply. We have a standard resistor here, which is, both of these are 1 kilo ohm resistors, and they're separated on a board. Now the tolerance inside these resistors is plus or minus 0.01%. So they're a high accuracy resistor, and they will be used to test how accurate our measuring device is here. We also have a standard resistor here, which is 1 ohm resistor. You can see it's a bunch of resistors that are all in parallel, so their resistance is reduced. So this should be 1 ohm. You also have this stainless steel resistor mounted on a board. It's just a wire, stainless steel wire. Remember, we're trying to find the resistivity of the stainless steel. So this is the wire that we're going to use. And you've got a bunch of different probes around the place, just wires. You also have a vernier caliper. You're used to using one of those by now. And that's going to be used to measure the diameter of the wire, because that's an important part in our equation, equating the resistance to the resistivity. So we're going to use our high quality resistors, these 1 kilo ohm resistors, to measure the accuracy of this guy. Now, something to point out to start off with is, when you're making connections with these guys and with power supplies, ensure you turn the power off and on. Turn it off before you unplug anything, and then you can turn it back on once you're finished. So don't unplug anything while your power supply is still switched on, because that could damage the power supply. It could give you a bad shock and damage components and things like that. So just make sure it's switched off when you unplug anything. And it's a good precautionary thing to do that with your multimeter as well. Okay, so let's check that this does give an accurate reading. So take your wires, plug them into the resistor, and switch it on. And you can see that it's measuring 0.995 kilo ohms once we switch this to the kilo ohms dial. So you need to decide whether that's within the tolerance of 0.1%. And that will tell you the accuracy of this guy. So let's try then, turn your multimeter off. Let's take your resistors and wire them in series. So take some of these wires here, and if you connect this end to this end, these are now connected in series, and we can measure the resistance like this, and you'll see that that's coming from your multimeter through one resistor, back through another one, and back to your multimeter, so that's in series. So let's switch it on again, and you can see that measures about 2 kilo ohms, very close to 2 kilo ohms, which is what you'd expect for resistors in series. Switch that off. So let's see what happens when we measure in parallel. So to do this, we connect our resistors in this way. So basically we've taken both ends of the resistors and put them together, so they're in a parallel manner. And then we measure with our probe on this end of the resistor bunch and that end. Let's switch it on. You can see that the resistance is now half of what it was before. And you should check with your theory to make sure that's what you should see. And you should check with your theory to make sure that's what you should see for resistors in parallel.